All right, hey, so we're looking at solving systems of linear equations using elimination today. Um, that's our topic. So our first example is every day Brennan bakes chocolate chip and low-fat oatmeal cookies in her bakery. She uses different amounts of butter and oatmeal in each recipe. Brennan has 47 kilograms of butter. Oh, that's a lot of butter. And 140 kilograms of oatmeal. Determine the number of batches of each type of cookie that Brennan can make using all of the butter and all of the oatmeal that she has. Okay? Well, the recipes call for the following. It's 13 kilograms of butter and 8 kilograms of oatmeal. That's for the chocolate chip cookie. Whereas the low-fat oatmeal requires quite a bit more oatmeal, but and quite a bit less butter. All right, so 29 and 2. The goal is to use her butter and her oatmeal in the most efficient way possible. Okay. So what we're going to do here is we're going to, again, well, we have two variables here, a couple of variables that we're going to use. So I'm going to use C for chocolate chip and M for oatmeal. I don't want to use O because it tends to look like a zero, and it'll just get, in handwriting, it'll get confused. So I'm going to make one formula that represents the butter and one that represents the oatmeal. Okay? And in order to use all of her butter, she must multiply 13 kilograms times each individual batch of chocolate chip cookies plus 2 kilograms times each individual batch of oatmeal cookies. And she would like this number to be exactly 47 because that's how much butter she has. And for the oatmeal, she has 8 kilograms. 8 and 29 is basically going to happen. 8 times the chocolate chips plus 29 times the oatmeal should equal the total amount of oatmeal that she has, which is 140 kilograms. Okay, so this girl has a lot of stuff. So, what we're going to need to do here is I'm going to try this with elimination, okay? Where we're going to attempt to make one of these variables, C or M, in both equations, we want them to have the same coefficient, okay? So, I could multiply this number, and I could try and get the m to correspond to 29, but the issue is I'd have to multiply it by a decimal, or I have to double the 29, and I'd have to multiply this guy by 29 as well, okay? Or I could try and get the 13 and the 8, and then the 8 and the 13 to go. Well, I'll do that because these guys are sitting at the front, just because, okay? So what we're going to do is we're going to multiply this whole equation by 8, and then we'll multiply this whole equation by 13. Okay? Well, 8 times 13 over here is 104C, and 8 times 2 is 16M, and 8 times 47 happens to be 376. So what did I do here? I just took the 8 and I multiplied it into here, here, and here. And if you're still not sure exactly why, you'll see in just a moment, because what I've done is I've now taken 8 times 13 as the coefficient to C. Over here, I'll be doing the same thing. I'm going to take this 13 and I'm going to multiply it into each one of these values here, here, and here, okay? And we'll end up with a very nice situation. 13 times 140 is 1,820. So 1,820. 13 times 29 happens to be 377 M. And 13 times 8 is 104 C. Okay? So if you look closely, I've gotten it so that the C value here and here have the same coefficient. So now this is where the word elimination comes in. Okay? I'm going to take these two formulas and write them one over top of the other. All right? Maybe I'll get back into white. So I've got 104 C plus 16M equals 376. And this is 104 C plus 377 M equals 1,820. And now what I'm going to do is I'm going to subtract here. Okay, I should probably spell that word correctly. Subtract. Subtract. So if I end up subtracting this equation from that equation, I end up with 104 here minus 104. And so these effectively actually end up canceling out, which is quite exciting here. Let me get green. So those guys end up canceling out. Then I've got 16 minus 377 is going to be negative 361, negative 361, and that's an M. And then I've got 376 minus 1,820, which is going to give us a negative 1,444. Okay, and now I divide both sides by negative 361, negative 361. And I end up with the fact that the M is 4. Because 1,444 divided by 361 turns out to be 4. Okay? Now you might say, well, how am I going to get the C value? I'll take this formula back here again, or maybe this one. Up here, take this one. And I'm going to write it down. So 13 times C plus 2 times M. But remember, M is 4. We discovered that here. That equals 47. And so I've got 13C is equal to 47 minus 8 by 8, because I'm going to take this 2 times 4, and I'm going to subtract it over to the other side. 47 minus 8 is 39, and C equals 39 over 3. So C is equal to 3. So the lady, Brenna, here needs to have 3 batches of chocolate chip cookies and 4 batches of oatmeal cookies. Let's try another, shall we? So here we have, during a training exercise, the submarine traveled 20 kilometers per hour on the surface, 10 kilometers per hour underwater. And the submarine traveled 200 kilometers in a total of 12 hours. How far did the submarine travel while underwater? Okay, couple of variables, x and y. Okay. We're going to let x be the surface distance, so the distance on the surface. And we're going to make y be the distance underwater. And that's what we want to find is y. Okay? We know that x plus y is 200. They tell us that here. And we also know that the time traveled is 12, and that equals the time traveled, but we don't know how much time they traveled for each one. But let's go back and learn about, review a little physics. We know that velocity is equal to distance over time, okay? And you know that velocity is equal to distance over time, okay? So I'm going to put little x's here, here, and y's here and here. Focus on these two formulas here. So the velocity that the submarine had while traveling x, or across the surface, is equal to the distance traveled across the surface divided by the time traveled under the surface. So I'm going to replace this with the time traveled under the surface, and this is the time traveled under the water. Sorry, I said under the surface. I meant above the surface here. And so the thing that I'd like to do here is solve for this time variable in this formula here. And I'd like to solve for the time variable in this formula as well. All right? So if I solve for time in each of these formulas, it's going to look like this. Time of x is equal to x over velocity x. Time of y is equal to y over velocity y. Okay? That's just due to some cross multiplication, because I'm going to multiply. Let me explain that a little bit better. Okay? What I'm actually doing here is multiplying by tx on both sides and dividing by Vx on both sides. And effectively, this Vx cancels with this, leaving me just a Tx. And this Tx cancels with this, leaving me an X over Vx. Okay? And then I do the same thing for the other equation there, the y, the one that deals with y's. So as a result, I realize that Tx is x over velocity x. And so I'm going to write down that 12 is x over velocity x. And I know that Ty, or the time traveled underwater, is y over Vy. Okay? Well, what are the V's? Those are the velocities, right? And it turns out that we're given this information, okay? You can close this thing here. I know that the we can do 20 kilometers along the surface. So I know that Vx is 20. And we're doing 10 kilometers per hour underwater. So I know that Vy is 10. So I'm going to go ahead and do that. So 12 is x over 10. Sorry, that's going to be a 20 there. I think I messed that up. This is a 20. Plus y over 10. Okay? Well, that's pretty exciting. Quite exciting indeed. So now what I've finally done is gotten to the point where I have two equations, one with an x and one with a y, and the other one also as an x and a y, and I can do elimination. Okay. Now, one of the problems is I have fractions here, and so you may have remembered at some point some kind math teacher showed you that I could multiply both this entire equation by 20. If I do, I get a 20 in each of these numerators, and 12 times 20 is 240, right? So 240. And this is 20x over 20 plus 20y over 10. Well, 20 over 20 cancels, and 2 over 10 cancels, leaving that. So I end up with 240 plus x, oops, not plus, this is equals x plus 2y. And now I'm going to see that I could do substitution here, but this unit is focusing on elimination. So I'm going to place one of these over top of the other, this one and this one, and I'm going to subtract. Okay, so basically what I'll do is I'll take this guy and I'll write him here. So that's x plus y equals 200. I'm going to write it like this. 200 equals x plus y. And I'm going to, again, subtract. I can subtract immediately right now because the x's have a common denominator, a common like term right here of a 1 and a 1. So I get 240 minus 200 is 40. X minus x is 0x, so these guys end up canceling. The x's cancel. And then I've got 2y minus y leaves me actually just a y, and I know that y is 40. Interesting. And that's all we actually needed. How far did the submarine travel underwater? And so that would be 40 kilometers. Okay, we know everything's in kilometers because it's kilometers per hour here. Okay, and here this is in kilometers as well. So the final result would be kilometers. All right then. Thanks for watching.